How you doing? I just wanted to touch base with you about the two last articles or columns that explain duration. I know this is not an easy concept and probably new to you, but it's the most important risk measure as far as the bond market. So I want in this recording, I want to touch about the explanation and the description of duration. What is it? What are the main components that affect duration? And then we're going to move on to the calculator and actually create a calculator for duration, and then we're gonna check how is it useful. Okay, so the first thing I want to touch on, and I'm just summarizing the two articles that you have in your module, is that duration is a way of measuring how much bond prices are likely to change if and when interest rates move. So that's the most important part of this risk measure. Okay, it is gonna tell us how much the price is going to move. Now think about the importance of this. If you are an investor that wants to have short-term profits by investing in bonds, then you should really pay attention to duration, because it will tell you how much the price is going to go up or down when interest rates move. Okay, remember that when interest rates go up, prices go down, and the opposite is true too. Okay, now duration is measured in years. Okay, and you will see later on that it's also a fraction of a year, and what matters is that it's going to tell us how much percentage the price is going to move. So if you read at this part, as a general rule, for every 1% increase or decrease in interest rate, a bond price will change approximately 1% in the opposite direction. So this is simple. If a bond has a duration of 5 years, that means that for every movement, every 1% movement in the yield rate, then the price is going to change 5%. Okay, so for every year 1% of the price is going to move, and we're going to see it in a couple of examples. Okay, in the other one, which is a more complicated and advanced explanation of duration, the one it's called advanced bond concepts, what I want you to pay attention to is this explanation of the balance and the lever is pretty creative. Okay, and what it explains is that duration can also be known as, I'm going to put in this image, can also be known at the moment in time where you're going to get back all those cash flows. Okay, so remember, when you have a bond, you have intermediate cash flows that are called coupons, and at the end you get the principal again, or the face value, right? Well, duration, because of interest rates and discount factor, you pay a price on day zero, and duration is going to tell you when exactly you're going to get all that price back in cash flows. Okay, so that is important, because the longer the duration, the longer it takes to get that money back. The shorter the duration, the shorter it takes that money back. So of course now you can assume by common sense that the higher yield rates and higher coupon rate bonds have shorter durations. Okay, because it takes less time to get that cash flows back. And the opposite is true. The lower the yield rates, the longer the duration. Okay, so I highlighted a couple of things about this second article. First one is interesting. Duration increases immediately on the day a coupon is paid. So think about it. Okay, when you get the coupon, it is no longer considering a future cash flows. You already have it. So on that day, the day when you receive a coupon in the bond, the duration increases significantly, because you gotta wait another coupon period to get payment. Okay, now it's never gonna be greater than maturity. Maturity and duration are only the same for zero coupon bonds, and write that down. For all the rest of the bonds, because you receive coupons in between, duration is gonna be lower. Okay, now another thing that I highlighted here is important is the factors that affect duration are, of course, there are two rates: coupon rates and yield rate. And this is what I just explained. Bonds with higher rates will have lower durations because you're going to recover the money faster. Okay, as opposed to low yield rates and low coupon rates, you will have longer duration. You will have to wait. Okay, now we're going to translate all these formulas that you have over here, and we're going to analyze how we can use it. So we're going to move to our calculator here. I want you to put in this side bond description, and you can pause this video at any time. So I'm not gonna stop. I'm gonna be fast, but you can pause it and write this data. Okay, we're gonna use this settlement and maturity dates because we're gonna try to use the Excel formula. Although we're gonna build our duration formula, we're gonna compare it with Excel's formula, which is a pretty easy and practical way to calculate it. Okay, so here we go. I assume that the coupon rate was 5% and the yield rate was 7%, and the coupons were paid every 3 months. So we have 4 coupons per year, okay? So that is important, okay? Now forget about this. Oh, I'm sorry, I did the exercise. I'm gonna do the exercise with this part, not this part. So I'm gonna hide this. Forget about that part, okay? Just focus on this one. Face value 100, coupon rate 9%, yield rate 7%. Now the period rate, because we're paying coupons every semester, it's gonna be 3.5%, which is just dividing it. It's a 3-year bond. It has 6 coupons, okay? And the coupon value, we just multiply by the face value and the coupon rate, and it's 450. All right, this is the present value of all the coupons, and this is just money markets, okay? And this is the present value of notional. So the price of our bond right now should be 105.3286, which makes sense because this is an over par bond because the coupon rate is higher than the yield rate, right? All right, this is how we build duration. And I think I mean, you're gonna see that you can use Excel function, and that's easier. And I totally agree. And when you go and work on these things in your jobs, use Excel as much as possible. But I also like to give these long explanations because for me, you get to understand where these formulas come from and how you can use them, how you can interpret the data. Okay, so here we go. Coupons. You're gonna have 6, and you have an extra one. It's not a coupon, but it's the payment of face value. Okay. Now each coupon is 450, as we know, and the last one, repeated payment on the 6th period, it's 100, which is the face value, right? Now this is just present value. Using yield rate, I'm gonna get the present value of 4.50 divided by 1 plus yield rate and elevate it to that specific period. Okay, so if you go down, you see that it's elevated by its period. Okay, of course my 100 payment goes back in time the same way. Okay, now because duration is in years, we're going to divide this period in years. Okay, this is a semester, every semester payment, so every semester goes 0.5, 1.5, like in 0.5 terms or periods of time. Okay, now if you multiply the present value times this period, what you're getting is a weighted or ponderated average of how much time that payment is gonna take, okay, to get back in present value. Okay, so if you ponderate this times the period, at the end of the day, including the face value, you have all these numbers, and I'm adding them all in present tense, okay, present value, okay? You have all these weighted averages. Remember, we're trying to translate our payments into years, okay? And I think that's important. With duration, you're translating the present value of all your future cash flows into a year term or a time term. We're translating money into time, okay? So you have that sum, and in order to get the duration, the only thing you need to do is to divide that over the price, the current price. Okay, so in other words, and this is that I think that's the most important part. In other words, according to the price you need to pay right now, okay, you will need 2.7 years to wait in order to get those cash flows back. Okay, now the modified duration, which is the one we're going to use more in this class, is going to affect it by the yield rate. Okay, you see it is just dividing in 1 plus the yield rate, and it's gonna tell us exactly, well, not exactly, but very, very close how much percentage is gonna go up and down in price when we move the interest rate. So that is very, very important. Okay, so let's check it out here. Okay, I put the settlement date at this and maturity date this, just to check out a 3-year bond. Okay, at every issuement of a bond you will see these two dates. Okay, and those are the dates. And I mean, they vary. They're not all the time they're exactly 3 years, because it could be over a weekend or a holiday. So it's gotta be a Labor Day, and these dates will help you use the Excel formula. Okay, so I'm gonna use it here. I think you can see it around here. It's called M duration, M for a modified duration, and it's gonna ask you first for the settlement date, the maturity date. Okay, then it's gonna ask you for the coupon rate, then the yield rate, and finally the periods per year. So it's pretty easy, and it will throw you back the modified duration. Okay, so this is important to put modified duration. Okay, so all that formula that you saw in your columns, I just translated pretty easily into what math is doing here. Okay, so why is this important? Okay, now we have duration of 2.6125, modified duration over a 3-year bond. Okay, well, if we get the regular price, 105.3286, what we're saying is, all right, for every 1% increase or decrease on the yield rate, I should have a change in price. How much would that change be? Well, it's related to this modified duration. Okay, so I put it in terms of modified duration here. So what I did is, to this price, because I'm increasing the rate to 8%, I'm gonna subtract that 2.61, but in percentage. Okay, it's 2.6125 percentage of the price. So if you see here, I'm multiplying the price times 2.6125 in percentage, and I'm subtracting it from the original price. So this should be my new price if I increase the rates by 1%. That's what the duration is telling me. So let's check it here. I'm gonna change to 8%, okay? And this new price is 102.6211, okay? Great. So it gave us a very, very, very strong approximation of how much the price is going to change. Now, it is not exact. Why? Because we're missing a concept named convexity. And if you see it here, that's the next part of this module, okay? Convexity. But for now, just stay with that, okay? Stay that duration, modified duration is a very good approximate value of how much the price of a bond is going to change. Okay? See you soon, guys. Thank you.